We found something outside our galaxy that shouldn't exist. A structure so massive, so impossibly large, that it violates the fundamental laws of cosmology. Scientists call it the Big Ring, a circle of galaxies 1.3 billion light-years across, arranged in a near-perfect ring around empty space. It was discovered in January 2024, and nobody can explain it. Our models of the universe say structures this large can't form. The math doesn't work. The physics breaks down. Yet there it is, hanging in space 9 billion light-years away, challenging everything we thought we knew about how the cosmos works. If you're ready to see the discovery that's forcing physicists to rewrite the rules of reality, hit that subscribe button. The mystery starts now. Alexia Lopez was a graduate student at the University of Central Lancashire when she found it. She was mapping quasars, bright, distant objects powered by supermassive black holes. She wasn't looking for anything unusual, just collecting data, creating a map of the early universe. Then she noticed a pattern. 15 quasars clustered in a ring. Not a loose collection, not a random arrangement, a geometric ring, nearly circular, spanning 1.3 billion light-years from one edge to the other. To put that in perspective, our entire galaxy, the Milky Way, is 100,000 light-years across. This ring is 13,000 times wider. Light takes 1.3 billion years to cross from one side to the other. That's longer than multicellular life has existed on Earth. At first, Lopez thought it was a coincidence. Space is big. Random patterns emerge when you look at enough data. She ran statistical tests, calculated the probability. The chances of 15 quasars randomly arranging themselves in a near-perfect ring, less than 1 in a million. This wasn't random. This was structure. Real, physical structure in the cosmos. She published her findings in early 2024, and the astronomy community went silent. Because this discovery breaks one of the most fundamental principles in cosmology, the cosmological principle. The idea that the universe, when viewed at large enough scales, is smooth and uniform. No direction is special, no location is unique. Structure exists, yes, galaxies, clusters, superclusters, but above a certain scale, around 1.2 billion light-years, the universe should look the same everywhere. The Big Ring is larger than that limit, way larger. It's not just a cluster of galaxies that happen to form together, it's a coherent structure, a ring. And rings don't form by accident. They require organization, symmetry, some kind of process that shapes matter over billions of light-years. But there's no known process that can do that. Gravity pulls things together, forming galaxies and clusters. Dark energy pushes things apart, accelerating expansion. Neither force creates rings. Neither force organizes matter into geometric patterns spanning more than 1 billion light-years. Yet there it is, undeniable, photographed, mapped, measured. And it's not alone. The Big Ring isn't the first impossible structure we've found. It's just the latest. In 2013, astronomers discovered the Hercules Corona Borealis Great Wall, a superstructure of galaxies stretching across 10 billion light-years. 10 billion! That's more than twice the width of the observable universe's radius at the time those galaxies formed. How does matter organize itself across distances that light hasn't had time to cross? It doesn't. It can't. The speed of light limits how fast information and gravity can travel. Structures can't form if their opposite sides have never communicated. Then there's the giant arc, also discovered by Alexia Lopez in 2021. Another massive structure, this one shaped like an arc, spanning 3.3 billion light-years. It exists in the same region of space as the Big Ring. In fact, the two structures might be connected. They're at the same distance from Earth. They appear to be part of the same cosmic web. Two impossible structures, side by side, violating the same fundamental principles. Scientists are calling these megastructures, and they're forcing us to question everything we think we know about cosmology. The standard model, the lambda CDM model, predicts how structure forms in the universe. Dark matter clumps under gravity. Normal matter follows. Gas collapses, stars ignite. Galaxies form. Those galaxies cluster together under mutual gravity, forming groups, then clusters, then superclusters. But the model has limits. Above a certain scale, structure formation stops. The universe is expanding. Space itself is stretching, pulling distant regions apart faster than gravity can pull them together. This creates a maximum size for structures. Anything larger than about 1.2 billion light-years shouldn't exist, can't exist. The math explicitly forbids it. Yet we keep finding them. The Sloan Great Wall, the giant void, the cold spot in the cosmic microwave background. Each discovery chips away at the cosmological principle. Each one whispers the same uncomfortable truth. The universe is not as uniform as we thought. Structure exists at scales where it shouldn't. Patterns emerge from chaos in ways we don't understand. Some physicists are starting to wonder if the cosmological principle is wrong. What if the universe isn't smooth at large scales? What if there are preferred directions, preferred locations? What if the cosmos has structure we can't see because we've been assuming it shouldn't be there? But that raises a terrifying question. If the universe has hidden structure at the largest scales, what else are we missing? Let's talk about the theories, because scientists don't have a good answer yet, but they have ideas. Some are mundane, some are radical, and some rewrite physics entirely. Theory 1. It's a projection effect. Maybe the Big Ring isn't actually a ring. Maybe it's a bunch of unrelated galaxies that just happen to line up from our perspective. Like how constellations look connected from Earth, but are actually stars at vastly different distances. This is possible, but statistical analysis makes it unlikely. The galaxies in the Big Ring are all at roughly the same distance from us, around 9 billion light-years. They exist at the same moment in cosmic time. It's not just a line-of-sight illusion, it's a real structure. Theory 2. Baryon acoustic oscillations. In the early universe, pressure waves rippled through the hot plasma before atoms formed. These waves left imprints in the distribution of matter, circles and spheres where matter concentrated. Most of these features are small, predictable. But maybe, under rare conditions, they could create larger rings. The problem is, baryons create spheres, not rings, and they max out at around 500 million light-years. The Big Ring is more than twice that size. This theory explains small-scale structure. It doesn't explain megastructures. Theory 3. Cosmic strings. These are hypothetical one-dimensional defects in space-time, cracks in reality left over from the Big Bang. They're predicted by some models of high-energy physics, but have never been observed. If they exist, they could be incredibly massive and stretch across cosmic distances. A cosmic string passing through a region of space would gravitationally attract matter, creating linear structures, maybe even ring structures if the string forms a loop. But there's no direct evidence for cosmic strings. And even if they exist, creating a ring 1.3 billion light-years wide would require a string of unimaginable mass and energy. It's theoretically possible, but barely. Theory 4. We're wrong about dark matter. Dark matter is the invisible substance that makes up 85% of the universe's mass. We infer its existence from gravitational effects, but we don't know what it is. What if dark matter doesn't distribute itself the way we think it does? What if it clumps in unexpected ways? Forms structures gravity alone can't explain. Some models suggest dark matter could interact with itself through forces we haven't detected yet. Dark electromagnetism, dark acoustic waves. These interactions could create large-scale patterns in how dark matter clusters, and since normal matter follows dark matter, those patterns would show up as rings and arcs of galaxies. Theory 5. Modified gravity. What if gravity doesn't work the way Einstein described at the largest cosmic scales? General relativity works perfectly for planets, stars, even galaxies. But maybe at scales of billions of light years, the equations change. Some physicists have proposed modified theories of gravity to explain dark matter and dark energy without invoking invisible substances. Maybe these same modifications also allow structure to form at larger scales than current models predict. The problem is, most modified gravity theories have been ruled out by observations. The ones that remain are highly speculative and lack direct evidence.
And then there's Theory 6, the terrifying one, the one nobody wants to be true. What if the cosmological principle is fundamentally wrong? What if the universe isn't homogeneous and isotropic at large scales? What if we live in a region of space that's atypical, a bubble, a void, a pocket with different properties than the cosmic average? If that's true, then everything we've calculated about the universe's age, size, expansion rate, and fate could be wrong. Our measurements of dark energy, based on assumptions of uniformity. Our models of structure formation, built on the principle that the universe looks the same everywhere. If the principle fails, the models fail, and we're left staring at a cosmos we fundamentally don't understand. Here's what keeps cosmologists awake at night. These megastructures aren't just anomalies. They're not outliers we can explain away with better measurements. They're real, they're confirmed, and they're multiplying. Every few years, we find another one, another structure that shouldn't exist, another violation of the rules. The Big Ring is 1.3 billion light-years wide. The giant arc is 3.3 billion light-years. The Hercules Corona Borealis Great Wall is 10 billion light-years. We're not talking about small deviations from the model. We're talking about structures 2, 3, 8 times larger than the theoretical maximum. That's not a rounding error. That's a fundamental breakdown of our understanding. And it gets worse. These structures exist in the early universe. The light we're seeing from the Big Ring left 9 billion years ago. The universe was less than 5 billion years old then, young, still forming. Dark energy was just beginning to dominate. Yet somehow, matter had already organized itself into a ring over 1 billion light-years across? How? Gravity can't build structures that fast. There hasn't been enough time. Unless something else is at play, some force or mechanism we haven't discovered. Maybe dark energy isn't constant. Maybe it was stronger in the early universe, creating pressure waves that shaped matter distribution. Maybe there's a fifth fundamental force operating at cosmic scales, invisible to our local experiments, but dominant across billions of light years. Or maybe the Big Bang itself wasn't as smooth as we thought. The cosmic microwave background shows tiny fluctuations in temperature across the sky, 1 part in 100,000. These fluctuations seeded structure formation. Denser regions attracted more matter and became galaxies. But what if there were larger fluctuations we haven't detected? What if the early universe had massive density waves rippling through it, creating the scaffolding for megastructures billions of years later? The James Webb Space Telescope is making things worse, not better. Webb can see farther and clearer than any telescope before it. It's finding galaxies that are too massive, too mature, too organized for their age. Galaxies that shouldn't exist yet. The universe at 400 million years old was supposed to be filled with small, primitive, chaotic galaxies. Instead, Webb is finding massive disk galaxies with spiral arms and organized structure. Galaxies that look like they've been evolving for billions of years, not hundreds of millions. Add that to the megastructures, and a pattern emerges. The universe forms structure faster and at larger scales than our models predict. Something is missing from the standard cosmological model, something big. Some scientists think it's time to abandon the cosmological principle entirely, to admit that the universe is lumpy, structured, and asymmetric even at the largest scales. Others cling to the principle, searching for explanations that preserve it. Modified gravity, exotic dark matter, primordial magnetic fields, anything that might explain the observations without tearing down the foundation of modern cosmology. But the evidence keeps mounting, and every new discovery makes it harder to ignore. The Big Ring is not an anomaly. It's a symptom, a crack in the facade of a theory that's been holding together with duct tape and assumptions for decades. We found something outside our galaxy that defies explanation. A ring of galaxies 1.3 billion light-years wide, existing in a universe where structures that large shouldn't form. It's not alone. Megastructures are appearing everywhere we look. The giant arc, the Hercules Corona Borealis Great Wall, galaxies forming too fast, clusters organizing too early, the universe refusing to follow the rules we wrote for it. This is science at its most uncomfortable, the moment when observations clash with theory and force us to choose. Do we trust the data or the models? Right now, the data is winning, and what it's telling us is terrifying. The universe is not what we thought. The principles we built cosmology on might be wrong, and if they're wrong, then everything we think we know about the cosmos, its age, its fate, its fundamental nature, is up for grabs. The big ring is out there right now, hanging in space, waiting for us to explain it, and we can't. Not yet. If this discovery shook your understanding of reality, hit that like button and subscribe to Space and Scale. Next time, we're diving into why NASA stopped exploring the ocean. The reason will blow your mind. See you there.